And now the answer to the question we've all been asking ourselves, what is Revit? And this is the Autodesk website, and I will actually let them explain what Revit is. But I suffice it to say that if you're here to learn Revit, and you've been required to by me or by some other authority like your boss. So let's get to it. How do you get Revit? Well, if you are a student and you're new to Autodesk, you can log into their student website. And once you are logged in and approved as a student, you can go and get all sorts of Autodesk software, AutoCAD and whatnot. And here's Revit, and that's what we're going to get. By the way, you can install it directly, and this will use an installation tool. This usually works, but if you have a lot of virus protection on your computer, sometimes that doesn't work so great. And you have to download the whole kit and caboodle, and that can take quite a while. So just be forewarned. If you already have some Autodesk products, if you look in your system tray, there's a little Autodesk desktop app widget. And this widget will have all of your Autodesk software on there. And this is where you can go and get new Autodesk software very easily. And this is also handy when there are updates, which is pretty much all the time, or at least twice a year, I would have to say. There's usually one new issue and then one update. So I have launched Revit, and now I'd just like to take a moment to describe the overall strategy of these videos, which is to say I cannot show you everything that is available in Revit. However, I can show you the basic elements that you need to produce a fairly rich and complex building model. Now, there are always more types of things that you can do, different types of shapes, different types of objects, and I will allude to those. But my overall strategy is going to be start with the simplest procedures, the simplest way of doing things. And then, as we move farther along in these videos, get to the more complex elements or to the richer array of options that exist within the simpler elements that you begin with. And this is great when you're in school. I want you to be able to produce a project for your classes quickly and easily without getting bogged down by the kind of hyper level of detail that's typical of a building information modeling software, which is what Revit is. So let's get started. And what I'm going to do is open up a new project here. And the first thing to realize about Revit is it's not just a drawing, it's a project, and I am holding up my fingers in quotation marks. And there are all sorts of templates which you typically use. If you're in an office, of course, use your office templates. For us in architecture and interior school, and the Imperial Architectural Template is fine, or the metric one if you are in the other 95% of the world that uses the metric system. And I'll just choose that one and click OK. And I have skipped through the launching of Revit and the opening of this file, but needless to say, even on an older computer, Revit actually can run fairly well, but the fewer system resources you have, the longer it will take to launch. It can actually take a really long time. So this is the Revit interface here, and it is fairly similar to other drawing programs, and I'm going to have to assume that you have learned some other drawing programs. First of all, the majority of the screen is taken up by this drawing area. There are some toolbars or tool ribbons, depending on how you want to call it. There's a couple of quick launch buttons up here, which are handy-dandy tools that are used frequently. And then on the left here, this is the Properties menu and the Project Browser. Okay, down at the bottom of the view, here are some view-specific controls. You can also control a lot more detail. Like I was saying, this is the higher level of detail. Here in the properties, when you have nothing selected, the properties shown are the properties of the view. So we can control, for example, the drawing scale, and the level of detail that's shown. Now, the best use of Revit is for things like construction drawings and complex projects, complex architectural projects. And to that end, it starts you out in floor plan view. It is a program which develops a single three-dimensional model based on whatever elements you put in it. The trick is that you can view that model in many different ways, and these symbols down here should look familiar. They are exterior elevation symbols. So I can draw a model in plan, but I can also view it in 3D views like elevations and sections. But interestingly enough, because it is a building information model, every object you draw has information about it, how big it is, the area, the construction techniques used, and you can extract that information in other types of views, for example, a door or window schedule. And this is what makes building information modeling so powerful. So let's begin learning some of the basic tools, and what I'm going to do is basically go across the top toolbar, and we'll draw simple objects based on these tools using the simplest options. I will allude to where the higher level of options are, but not too much. I don't want to confuse the early learner of the program. So first of all, the wall tool. What you will notice in Revit, like other Autodesk software, and frankly like a lot of software, is that if you leave your mouse over the tool, it will actually have a pop-up window that shows you how to use the tool, and you can hit F1 for help, and it has the keyboard shortcut and all that. You will also notice underneath the tools, kind of Photoshop style, there are other tools hidden. And some of these we don't know what they are yet, and some of them are sort of ill-advised. So usually the topmost tool is the kind of most commonly used tool. So let's try and draw a wall. Click on the wall, architectural tool. And you can draw like in any other program. Just click once to start drawing. And it is a click and draw tool as opposed to a click and drag tool. And let's draw a wall 25 feet wide. And you can see here that the cursor is a smart cursor. We have seen these before. It will snap to horizontal and vertical directions, and it will also snap to a dimension. So I'm going to draw a building, say 25 by 50 feet here. And already you can see it's drawing a double-lined wall. And this wall actually has properties, and you can see them up here. It's drawing a chain of walls. You can offset it from the spot that you're clicking on. And of course, if it's round, you can draw a radius. Also, when you draw a wall, like a lot of tools in Revit, there are different ways to draw them. I could draw it as a rectangle, or as an inscribed polygon, or an arc. So you can make this double-lined wall all sorts of different shapes. Also, right now we are using a basic generic wall. There are many other wall types in that menu, but we're going to stick with the simple one for now. Now, as you drag your mouse along, you can see the good old smart cursor will help us out by aligning with other objects. And then you can see there's a dashed line in the middle of this wall, which indicates that we are going to connect with it. And it heals that joint. See how it makes a nice clean joint, looks very architectural. The other thing is you can click on the dimensions after they're in place, and if I say want this to be 30 feet, like magic, I can make it 30. Control Z undoes, by the way. Control X and Control C work just like in other programs. Control is paste and copy. And I can scroll in and out just like in other programs. If I click and drag the scroll wheel, that is pan. Now, if you're one of those naughty people who has forgotten your mouse, kind of chronically, there is an option here, this 2D wheel. It's a sort of a steering wheel. You can click on the tool you want to use. Zooms in and out around the position of the wheel. Rewind is an interesting one because it will go backwards in time to your previous zooms. So if you've kind of gotten lost inside your project, that's kind of a real helpful option. Anyway, there are also, if I X out of this, Other zoom commands, which are probably going to be familiar to users of AutoCAD or SketchUp or Rhino. Now, other fun things that you can do. If you miss that dimension string, you can select the wall and reveal the dimension string. To do that, use the modify command. It looks like an arrow, kind of very familiar to SketchUp users. You can also type in MD for modify. Click on the wall, and what you'll find is that the dimension string will be revealed depending on which direction you're looking at. If I want that horizontal dimension string, I have to click on the side wall. If you want the dimension string, and you can come and edit it, if you want it to remain permanent, just click on the little icon down below, and now the dimension string will stay glued to your screen. And this is great if you're kind of not sure exactly how big you want something, you want to make changes. In fact, I can use the arrow key, this is called nudging, and I can nudge the wall left or right to be able to get whatever size that I think is best for my design ideas. So making those walls was really fun. Let's add some more architectural elements. Let's start with a door. Now, unfortunately, we do need to talk about family. It always comes up. And with every type of component in Revit, you will find that there are different families, and then within each family there are sort of different family members. Now in this case we have the single flush door. I'm clicking on the name of the door that pops up when I click on the door tool. And there are different, this is a type of door, which is a flat door, and it comes with trim, as you can see in the icon. And there are different types of family members. So these are called family types. Yes, you got it. So I'm going to choose a nice big door, 36 by 84. What you'll find is that when you do other types of objects, types of components, there are going to be a lot of family options. Now, when you draw in Revit, there are different types of ways you can draw. You can just use the reference dimensions. I'm going to put this door right in the middle. Okay, and you'll notice as I move my mouse, it kind of responds to where I place it. So I'll click to place the door. I'll zoom in here, and these are the flippers. You can flip the direction of the door. You can make it go in or out and have it be a left or right swing. Okay. And a lot of times you already have a door in a project and you want another one that's similar. I could just go back to the door tool and it will have the last door I used available. But I could also use this create similar option. I use this all the time because I often don't want to have 5 different kinds of doors and I can't for the life of me remember which ones are which. So I'll just select one that is used already in the project and click on this tool and it will insert another one. Let's try adding this door just a couple of feet off of the side wall, perhaps 2 feet off the side wall. And like we saw with the walls, once you've placed the object, you do have a dimension string available and you can change the number. I think I'll make it 2'6". Note to self, any dimension that you type in Revit, say if I type 3 and I just hit enter, Revit assumes that those are feet. So I could also type in 2.5 and that will be 2.5 feet or 2'6". So how about some more architectural elements? Let's go and try a window family. I'll click on the window tool and up here in the properties menu, I'll click on the down arrow and you'll see all sorts of different kinds of windows. Here we have casement, double casement, and double hung windows, and you can choose a window size, and maybe I'll come in here and I'll place a window some distance from the edge, maybe 3 feet. Works pretty well. And do note that the sash goes on the outside. Now when you place a new window, you'll see how it gives you a reference to the center line of the previous window placement. So for example, if I want these to be 3 feet on center, which is the typical way you measure windows, Revit knows that that's the typical way you measure windows, and I can quickly place 3 windows all at 3 feet on center. What if I want to make copies of these windows on the exact opposite side of this back wall? Pretty easy, very similar to other programs. I'm going to use the Modify tool to select them. And here, our knowledge of other drawing programs comes really handy because Revit uses the same type of selection options. We have a selection window versus a crossing window. In fact, they even use the dashed line versus solid line. And if you remember, anything that touches a crossing window gets selected. You can see the walls are highlighted. Whereas anything that is entirely contained within the selection window gets selected, not anything that's touched. So the walls are not selected, just the windows. So I'll select these windows. You can also, by the way, just click on an object, and if you hold down Control, see how there's a little plus sign next to my cursor? Then an object is selected. You can also hold down Shift to remove things from the selection set. So Shift and Control, a little different than other programs, but nonetheless works just fine. So I have these objects selected, and all I have to do is find the mirror command. Well, Revit is so smart, it knows that once you've selected some objects, you're probably going to want to modify those objects. So the Modify toolbar pops up. And here you can hunt around and look for the icon that looks like what you want to do. Some of these should look very familiar. Move, copy, and rotate. And here we have mirror, where you pick an axis, and here's mirror, where you draw an axis. So quite simple and really very familiar for those users of other programs. I'll click mirror, draw an axis. I'll look for the midpoint of this door, and if you're familiar with other drawing programs, you know that these are called O-snaps. And in fact, Revit uses pretty much the standard O-snaps that you'll find, again, in AutoCAD and in SketchUp. So I'll use midpoint. It snaps to vertical. I'll click once to define the vertical axis, and here it has made a copy. You can also mirror where it doesn't make a copy. It's just an option up on the toolbar. So what do these windows look like in elevation? Well, it's pretty easy to see. We know that Revit has actually already drawn the elevation. This is the elevation drawing here. There's a couple ways that you can view it, but the simplest one is just to click on the icon and go to the option Go to Elevation View. And here is my beautiful elevation. This elevation is a view type. So there are different types of views, and if you look down here at your project browser, there are a description of the different kinds of kind of groupings. There are floor plans. I can close or open that grouping. There's ceiling plans. These are each generated based on what are called reference levels. And this is kind of how Revit organizes the three-dimensional geometry in your project. So elevations, you can see they're already labeled. Revit uses the industry standard of north is up when you're drawing. You can, of course, define north as anything you want, but the kind of graphic standard is you start drawing with north up. And obviously the levels, each level has a floor plan and a reflected ceiling plan. These levels can be adjusted. So for example, I can select one. Here, I'll just select level 2. And first of all, I can rename it. So level 1, I might click on the text, kind of click on it once, and then pause momentarily and click on it again. And you can rename it ground floor, for example. And what will happen when I hit enter, it said, would you like to rename the corresponding views? And the reason it's asking me that is it's going to rename the ceiling plans as well if I say yes. You don't always say yes, but in this case, I'm going to be amenable. And this level 2, I could rename it, and I will, to mezzanine. Mezzanine, because we're going to have a little mezzanine here just to give us something to draw. And again, yes, I want to rename the view. So these views, these reference planes can be modified quite easily. I can nudge them like I've done with other objects. I could also use the move command if I want something more precise. I think I'm going to go with 12 feet between floors. Oops, that's 12'6". There we go. By the way, when you nudge and you zoom in, the nudging amount is proportional to the view of your screen. So you can see here that it nudged just a little bit when I zoomed in. And I can also use the copy command and copy it up exactly 12 feet. So there we go. I have level 3, and I'm going to rename level 3 the roof. Now, there is no reflected ceiling plan for the roof because I've just made that level and it doesn't automatically create one. Why doesn't it automatically create one? Well, I don't know. Just ask Revit. Now, I'm going to select one of my walls from my exterior of my building, and you can see there's a little arrow that pops up. That's called a grip or an adjuster, and I can adjust the height of this wall very easily. I can also make it snap to the roof. See how the roof reference level is highlighted when I snap up to it? And I can even lock it to that level. And this is how reference planes work in Revit. They are meant to be objects which you can define as points in space that other objects are kind of glued to, or not. Now, another way to attach these objects is through their properties. Now, I'm going to select this wall. And in fact, I think I want to select all the walls. And I could easily use my crossing window and get all the walls that way. But Revit has another way, and that is select one of your walls, right-click on it, and in the context menu, you can select all instances in the entire project of this wall. Now, I know I only have 4 walls, so it's easy enough to do. But do be careful with this option, because you can sometimes select walls in other parts of a larger project. But I'm going to select them all, and you see they're highlighted here. And now in the properties of the wall, so I'm actually going to move the top of the wall, not by graphically dragging on it, by changing the constraints on the top of that wall. And you'll see here where it says top constraint, I can just choose a reference level. So these reference levels are so handy because now my whole building is as tall as that roof level. And if I go and modify the roof level, look, the walls just keep going. They are adjusting based on the reference plane and not on some graphical constraint. Now, what if I want these windows to occur on the second floor? Well, what's fun about Revit is that you can select objects in any view. So I could easily draw a window around these objects. I could also select all instances in the entire project. Just be aware, like any 3D modeling program, that if there's something behind these windows, I can accidentally select those. So sometimes it's not a bad idea to check this filter option. I'm going to check filter, and you see how it says, oh, you have 6 windows. And you'll want to make sure if you have other objects like doors and things that were behind that you didn't see, that you unselect those, and it will allow you to do that. Now, I could just copy these windows by using my copy command, but and I'll show you how that works. You click copy, and you can move them up to some upper level, and then you can move them around. Once they're placed, you can select them and nudge them into place. I'm going to hit Control-Z and undo. Whoops. There we go. But I'll show you another little trick, and this is, again, we are talking about reference levels. I can copy these, Control-C. I could paste them in, Control-V, and you'll see that the windows become connected to my cursor. But Revit knows that when you copy something to the clipboard, it becomes available, and these objects all use reference planes, so I can actually paste aligned to selected levels. And this is such a handy feature because now I want all these to be exactly the same height above the floor. That's the sill height, but I want them on the mezzanine. I'll click OK, and the windows occur in exactly the same location in terms of their height above the floor. This is very architectural. You wouldn't have a tall building with windows sometimes 3 feet off the floor and sometimes 2 feet off the floor. So this is a really terrific and handy feature, especially in a larger building where you may have dozens and dozens of windows. The next type of family that we're going to add is a component. This is just like components in good old SketchUp or blocks in AutoCAD. Just click to add one. I'm just going to use the default one here, which is a desk, but you can see there are actually some other ones already in the model here in the project. And the desk is fine. There are a couple of options. It doesn't really matter. We're just learning how to use them. And like other objects, there you see the reference dimensions. You can click to place the object. It wants to place more, so you're already in the multi-placement mode, which is handy. And obviously, once the component is in, it can be copied. You can even just hold down Control and click and drag, and you'll make a copy. Also, that's using the modify command. So there are many different ways that you can make copies of objects in Revit. So as I mentioned, there are some of these component families already loaded into the project. What if you want more? Well, then you have to go get them. And the easiest way to go get them is go to the Insert tab. You can load a family that is on your computer quite easily. Now, I don't have any handy. You can also use the Autodesk library. And this is a cloud-based library that's constantly updated of different products. I'll just click on that one and launch the library loading menu. You can see here it's got a whole bunch of models that pop up, and they're a little funny looking. They have these reference planes that you can see. But you can click on the area that you want to add, say furniture, and maybe we can add some filing cabinets, because you always need filing cabinets. There's not a lot, so if you're really into furniture, for example, this is not really where you're gonna have much success. But you can get some basic furniture. Maybe I'll add a Corbu chair because it looks so nice. Load it into your project, and it becomes available. You say, well, where is it? I don't see it. You've only loaded it. You have to go to the component menu, and usually whatever you loaded is the most recent model. Sometimes there are family types available. So there's 3 family types here under the desk. There's only one Corbu chair. I'll place that chair right there. Now, if the Autodesk library isn't enough for you, it's time to hit the internet. One of the more popular sites is Revit City, and you can search for different things in their downloads, and you can see here they have a whole CSA organized section, or CSI section organized library of models. I searched for chairs, and you can see there's quite a few different chairs that you can just click on, and you can download one, or you can download a whole bunch all at once. There's also manufacturers' websites which you can go to, and many of them have quite functional and nice looking models. Revit also has columns that you can add, and this is another family type. One interesting thing about this family type is there are 2 main branches of the family. One is a structural column, and this is actually meant to define the structural system in the building. Now, we don't always have knowledge of what the structural system is in our projects, so we usually just use architectural columns. And when you're working in an office where it's a real project, they will probably have real structure so that the building does not really fall down. And obviously, you'll have a structural engineer in those cases, and they will give you the structural grid and the structural columns. Now, in our case, I'll choose architectural column. Like other families, there are often family members, family types. I'll just choose a small rectangular column, and this is going to support the edge of our mezzanine. Now, I think I'm going to place it about 15 feet off the back wall. You see here I'm using the reference dimension. By the way, you'll notice that I scroll in and out during a command. This is a transparent command, and this is a great feature. I can both scroll in and out, and I can also pan. So I'll click to place the column. I'll select the column. Now, what if I want that column right in the middle? I want it to align with this door. Well, guess what? There's an align tool, and this is also a very architectural tool. It's right here. When you've selected the column, the modify toolbar pops up, and here's my align command. So I'll just click on it. First, you click on the aligner. Now, you might think, well, how do I get the middle of it? Revit knows that you typically measure complex objects like doors and windows from their center line. So I can just click on this center line, see the blue reference line. Now it's giving me a dashed line. Whatever I click on will get moved to that position. So I could click on the face of this column, but I'm going to click on the center line. Now, again, whenever you use some of these tools like reference planes, you can lock it to that position. And I think I will do that because I don't want anybody accidentally moving my column. Like a lot of objects in Revit, roofs or roofs want to be placed in specific view types. So for example, it's much easier to place columns in floor plan. Windows can be placed in plan or in elevation. Roofs want to be on the site plan. So I'm going to go over to my project browser and double click on the site plan. And while we're here, let's take a look at what we see at the top of our screen, which is a bunch of tabs. Each of the views of your project is available as a tab, and these can be opened or closed. I can close one. If I click this red X up here, that closes any inactive view. So now I just have the site plan. I just have that one tab. And I think I'd actually like to have a 3D view of my model to be able to look at the different roofs and how they're constructed. To do that, there is a default 3D view. This is an axonometric view. And I'm just going to click on the little house here at the top of our screen. And because this is such a common view that you'll want to use while you're modeling, they make it as a quick shortcut. And you can, in this view, you can add and subtract. You can add windows and things like that if you wanted to. It's great. There is a view cube up here, which you can actually click on to modify. You can also hold down Shift and click and drag your scroll wheel. And when you do that, it allows you to kind of orbit the model. And again, orbiting is a term that we'll see in any of our 3D modeling programs, SketchUp and Rhino and the like. Now the other thing you can do when you have multiple tabs open, and I just have these two tabs open, is you can tile your windows. You can type in window tile, WT, and what you'll see is now I have one window with my axonometric view, my site view, the other window has my site view. And this is really handy when you want to do what I want to do, which is put in a roof and explain what's going on as I create the roof. So I've clicked on the site plan view, and now I will click on the roof by footprint. So I'm drawing in the site plan view. And again, as with other commands, there are different ways to draw roofs or roofs. And roof by extrusion will draw it by actually a vertical kind of profile. But let's just go with footprint because that is the easiest way. And as I mentioned, we are starting easy and get harder later on with more difficult tasks. So it will want to know which level you want the roof to be on. Now, we have already discussed levels, and roof is the one we created for the roof, as you might imagine. Choose yes. Now, you may have noticed that the whole model kind of went gray. This is what's called sketch mode, and complex objects in Revit are created in sketch mode. And for us, the roof, there are different ways of sketching. The easiest way, and the most typical, is to pick walls. So I click on a wall, and you see how it drew a little purple line. And if you just pick on the 4 walls, Revit guesses that you want the roof to go to the outside of that wall. The sketch has to have a continuous loop. It has to form a closed shape, and you can see here that it does. If it doesn't, if you accidentally click on a wall and you see how my purple lines don't meet here, you can use some of the editing tools. I could just click on the grip at the end to join them. See how it makes that horizontal line highlighted for a join. I could also use this trim extend to corner tool and click on the 2 lines and it will join them right there. Sometimes if you're kind of freehand sketching a roof, if you want an unusual shape, it's nice to be able to do that. Now, I'm just going to click the Finish Edit mode to end sketch mode. And what you'll see here in my 3D view is a roof. It's actually a hipped roof. And the reason it's hipped is because each of those 4 lines defines a slope. So it's the edge of a sloped portion of the roof. That's how Revit creates roofs. Now I'm going to double click on the roof to bring it back into editing mode and show you a couple of things. First of all, if I say nudge each of these lines out a little bit and finish the sketch, I now have a roof overhang. And this is a way that you can create different kinds of roofs. I can also, I'll just go back into editing mode, I can drag these to the inside of the wall. And this is actually what we're going to do because I want to have a parapet. And the way I'm doing this, if you're paying attention, it will snap to that interior line. Now, sometimes you have to kind of drag the wall away, the roof line definition, in order to get it to snap appropriately or zoom in and out. So now when I click check, you can see that the roof is actually inside of the outer walls. And to create the parapet, I can just select all of my exterior walls, and I'll give them a height which is above the reference level. If you remember, I set the top constraint to roof. I could set the top constraint to 2 feet above the roof. Now I have a parapet. The last thing I want to do is make this roof flat. It's kind of silly to have a parapet and a sloped roof. And of course, we know there's really no such thing as a flat roof. Roofs always have some sort of slope so that they drain. But this is where this little symbol, this angle symbol, becomes important. That angle symbol means that this line defines the roof. Now, here in the US, we define roof slopes by rise over run. I can actually click on this and change the rise over run, but the easiest way is actually to just select all the lines, and up here on the kind of context menu that pops up when you have objects selected, I can just uncheck this option. When I do that, the little purple angle goes away, and now when I click the checkbox to finish the editing, I have myself a lovely flat roof. So to create a ceiling, which is the next type of object we're going to create, you want to be in the ceiling plan view. And if you think about it, you're not going to see a ceiling in a floor plan. You're looking the wrong way. So we want a reflected ceiling plan. I'll just open it here. And by the way, I have my windows tiled. I typed in TW to tile the windows, or I can untile the windows. WT stands for window tile, and that opens it up again. And you might say, well, why do I need this big 3D view to when I'm putting in a ceiling? The reason is I want to show you the different types of ceilings and how they work. In this 3D view, I'm just going to click on it to make it my active view. I can turn on what's called a section box. I'm going to go here. I have nothing selected, and I'll go to the properties of the view and scroll down in there till it says section box. Turn that on and apply. And you'll see this box, and when I click on the box, what this allows me to do, I can first of all change what is visible by dragging in the edges. And you see when I drag it far enough, now I can see inside the building. And this is just really handy when you want to be able to see, for example, what kind of ceiling you're created. You can also see the lovely desks and chairs sitting on the floor, and the column that I have created that is sitting in a lonely way in the middle of the space. So I will click off it. Interesting enough, in plan, when I have the section box selected, I can actually continue to modify it. So for example, if I wanted to cut away more of the building to see more of the back of it, I can do that. This is actually kind of handy at different times. I can also just click off of it. Once I click off of the section, it is no longer visible in other views. So sticking in a ceiling is super easy. I just click on the ceiling tool and Revit will guess as to where I want the ceiling. In the ceiling plan, you see how it has this red line? That is Revit determining the edges of the room. I just click inside the room and I have an instant ceiling plan. And this is just a 2x2 ceiling. I can click on one of the lines on the ceiling. You can actually nudge it up and down if you want to change the centering. You can also change the family type. And there are a few types of ceilings Here, 2x2 is a familiar type of ceiling. Now, I usually use either 2x2 or 2x4 initially because if I change it to gypsum board, which is a nicer ceiling, look at what happens. I can't see anything. It looks like there's no ceiling at all. So I'll go and I'll change this back to a 2x2 to make our lives easier. Other features of the ceiling, when I click on it, I can change the height. Now, of course, I could use the arrow keys and kind of nudge it up and down, but we do tend to be a little more precise. If I make this, say, 10 feet, it will move it up. Just have to watch the section for the ceiling to move up and down. Now, I don't really want a ceiling over the entire first floor, but sometimes ceilings are difficult to select in order to delete them. I can select one line, but I cannot hit delete and delete the entire ceiling. You need to select the edge of the ceiling. Now, there's two ways to do this. In the reflected ceiling plan, I can move my mouse over where I think the edge is, and I can, I'll get a little tooltip which says what Revit thinks I want to select. And if I hit the tab key, now it will change and say, oh, I guess you didn't want that other thing. You don't want a single wall. You want the whole chain of walls. If I hit tab again, usually it will give me the ceiling plan. So I just have to hit tab a couple of times. Now when I click, you see how it's highlighted and selected. And I can just delete it. I could also go over here to this view. I'll deselect. And in 3D view, it's actually a lot easier to select the ceiling. You see how Revit immediately guesses that that's what I want to select. And I'll delete it. Now, the reason I'm deleting it is because I don't want a ceiling over this area. This is going to be open, and this is going to be a mezzanine. So I could just want a ceiling in this area. In fact, I don't even want it to go all the way to the edge. In this case, I'm going to do what's called sketching a ceiling. So normally it automatically generates a ceiling. Now I'm going to sketch the ceiling, and here I'll go with my 2x2 system, family type. Perhaps an ellipse would be fun. I don't know. I guess ellipses can be fun. And we'll just click once to define the dimension. Now, once these objects are in your model, you can continue to manipulate them, grab them by their grips to change their shape. You can even rotate them. And there's other tools such as trim, break, mirror, that sort of thing. But they do have to form a closed loop in order to make the ceiling work. So I'll just click the checkbox here. Now I have a ceiling, it's a 2x2. I like, as I mentioned, to be able to see the ceiling. Because this is a kind of a cloud type of ceiling, I can use this gypsum board on metal stud option because I'll still see the edge. And I can also continue to change the height. Maybe I'll make this one at 10 feet. Sounds good to me. And apply. And again, you can see the ceiling move up in the other view. Now, ceilings are sometimes used for other objects. We can absolutely draw in beams using the beam tool, but often for interiors projects, the beams are covered in gypsum board and you have lighting that's glued onto them and wiring that's hidden in the kind of false surface of them. So often we will use a ceiling as the representation of a beam. Now, this is a little weird, and remember, you can't put recessed lights into a structural beam. But again, for interiors projects in particular, you'll have a lot of surfaces which are kind of, I don't want to say false, but faux perhaps is the right word. So I'm going to click the ceiling tool. I will sketch the ceiling, and this time I'm going to draw a rectangle here, and I'll draw it so that it is representing a beam here. And again, I'm using a lot of the snapping features so that I can quickly draw what looks suspiciously like a beam on top of this column. What I can also do is when I click off of the lines, which represent the boundary of the ceiling, I can change the height of the ceiling here before it's created. And right now I said that the floor-to-floor height is 12 feet. I know that the second floor is going to have a 12-inch thickness, a 1-foot thickness. And I think this faux beam that I'm creating is going to have a 1-foot thickness. So let's put this up at 10 feet. And I'll hit apply. apply or not. Interesting enough, while I'm sketching it, the sketch appears on the floor in my 3D view. It'll move up once we're done. The other thing that I can do, I don't want a 2x2 ceiling, and I don't want any of these other families. So now I'm going to create my own family. Isn't that nice? Create my own family. The way you do that is you click on the Edit Type button. And remember, I'm still in sketch mode. I'm still drawing the ceiling. And here is where I can take one of these systems, say gypsum board, and I'm going to duplicate it. And maybe I'll call this faux beam, or soffit, because you often use this as a soffit. Click OK. And right here you can see there is a thickness associated with this beam. Well, where does this thickness come from? Well, now we get into the sort of more complicated elements of Revit, which is to say things have a structure. If you look here, there's a button we can click on in the menu for the structure of the ceiling. And now you can see the structure is metal studs, which are 3 5/8 inch, and the drywall, which is 5/8 of an inch. Now, because we are now making a custom ceiling, we can make this really anything we want, and I think I'm going to make this 11 3/8, and that will give me a total of 12 inches as my soffit. Now, of course, anytime you create these elements, you will find that they have customizable abilities. In fact, you can even preview what this looks like in section here, that I have this thick layer of finish and then this structural layer. And this becomes much important later on when we do actual detailed drawings. Anyway, I'll click OK and apply and OK. And like a lot of times in Revit, you don't see anything change. You're really just entering numbers in menus. You don't see the change until you click this Finish Edit mode. And now you have what looks suspiciously like a beam. And we do need to shorten the column. Again, in Revit, because you're often not drawing things but changing properties in a menu, I need to select the column and change its height to be 10 feet. And the way you do that, there's a couple ways, but a lot of objects, like walls, we said, can be connected to another level. In this case, columns want to be connected to another level. So now we have to change their top offset to -2 feet and hit enter and apply, and you should see the column shrink down to its appropriate size. The last major building element that we're going to create is a floor. And I have tiled my 3 windows so you can watch it all, both in 2D and 3D. And when you click on the floor tool, and again, like some of the other tools, there are other flavors of floors, including a structural floor, but the architectural floor is the one where you don't have to worry about it too much. Also, like other tools or other family types, there are many different kinds of floors. I believe that the generic 12-inch floor is the default one, and that's what we're going to use because we just don't want to think about too much in terms of the structure of the building. I'm going to start by drawing on the ground floor. Now, whatever view is your current view, the system will say, oh, well, I'm assuming you want the floor there. So that's why I have the mezzanine here. If I had the mezzanine as my current view, that's where it would put the floor. And in this case, we have the option to pick walls. And again, like with the roof, you can click on the walls, and this is usually the best way to make sure that the floor is aligned with the walls. Okay. Also, you'll notice that here it has put those lines on the inside of the walls. That's obviously what you would want with the floors. They don't usually go all the way through. It's also giving me a warning, hey, you knucklehead, you haven't saved your project recently. And of course you do want to save frequently. So I'm just going to click Save here to make sure. And as with other things, make sure that you save your projects early, often, and in a place where you remember where they are. That's usually my problem. Now, you can see here in the 3D view, and this is why I wanted it visible, that this does not look right. This is not how you build buildings. In fact, here I'm just going to click on the front view so that we can see this in kind of an elevation. We don't really have any footings in this building at all. Now, in a more complex project, we would draw separate lines representing the structural footings. The quick shortcut here is to select all the walls in the project, all the outer walls, of course, and just give them a base offset. I'm going to send them underground, and here in New England, you always want to go at least 4 feet underground, hit apply. And now you can see this looks more like a real section. We have a floor, we have a base to the wall, exterior walls, which goes underground below that ground level reference plane. And then here's the roof. And we can repeat the process to draw the mezzanine. You click on the mezzanine view to make it current. Click on the floor tool, use the same family. And in this case, I can use, instead of this pick walls feature, I'm going to draw a floor. And this is, if you want to do a stage or something like that. And right now, this edge of the beam below is about 15 feet 5. Let's move this mezzanine. We'll give it just a little bit more depth off the top. Let's make it 16 feet even. Again, using the dimensions to change the number, the actual position of the object. And you click the checkbox, and there you go. You have your mezzanine floor placed correctly in your 3D model. So we need to export a view of our project that can be shared with other people and submitted for homework even. And we can kind of tidy up our model just a little bit. First of all, I think I'm going to export this 3D view because it just shows what I've done. And I'll tweak the view angle so that I can see both the roofs and the windows and the doors and all the other good stuff that I put in. And of course, to do that, I have to have this section box. I don't particularly want to see the section box. In fact, I don't always like having it around anyway. When it's visible, it's kind of distracting. You can hide this element just by right-clicking on it and choose Hide Elements. You might say, well, wait, what if I want to change it again? The Reveal Hidden Elements button, this is a little light bulb, makes it show up again, and then you can right-click on it and unhide it, or just click on the Unhide button up here in the toolbar. But I'm going to leave it hidden for now and hide all the hidden elements. Other things I can do, each of these reference planes here, you see how it says roof? Well, this particular angle that I've chosen, I can't see the word roof, but I can check this little box here. That is the Show Me the Text button, or the kind of elevation bullet option. You can move that around, or you can have them both visible, either one. So that looks a little more presentable. The other thing I can do is, this is what's called hidden line view. And if you remember from something like SketchUp, that is a black and white view. No materials or textures or even shading is shown. And we haven't got any materials in here, at least not that we know of. But we can make this view a different visibility, make it shaded. This will help it to read a little bit. I'll just click on the little, looks like a sugar cube down at the bottom of our screen, and choose Shaded. And like magic, we can see the model pretty well. There are other options down here, consistent colors and realistic, probably better to save for when we talk about materials. So there we go, we have a lovely view of our model. All we have to do is click on the PDF button up at the top. And of course you can use a print to PDF button option if you have a virtual, say, Adobe printer. But this one will do just fine. And you can choose a number of things, including the current window, the visible portion of the current window, which is kind of like the extents. You can also check off here and print multiple views at the same time. You can even squeeze them into a single PDF just by kind of checking them off here. But I think for us, just the current window is fine. You can, of course, name it. I can call this axonometric here. And you can also choose where it goes. I think I'll just put this on the desktop. Now, other things, you can choose the page size. In this case, I'm not really interested in scale. I just want a big image that I can share. So I'm going to just choose ANSI B 11 by 17 and fitting it to page. If you are concerned about scale, then you would want it to zoom to 100%. And you would, of course, then want to check the scale of the drawing to make sure that it's going to fit on your sheet. In this case, I'm just going to squeeze it into the middle. The rest of these options we can kind of leave. It usually guesses if you want vector versus raster output. Raster output is usually when you've started adding a lot of materials. Click Export and wait for the PDF to come to life. And here it is. It's very nice. You can see that it's pretty good resolution here for a PDF, and it shows all the elements that we have created today. This is a great way to share your project with other people.